All right, modeling vertical free fall motion. So it says the height s and the vertical velocity v of an object in free fall are given by height. If I want to find the position that it's at, they call that s of t, and that's going to be equal to negative 1/2 times gravity times time squared plus the initial velocity times time plus the initial position, so how high it was at the very beginning. For vertical velocity, we call that v of t, it's going to equal negative times our gravity times time plus that initial velocity. Now it says where, underneath that it says where t is time in seconds, g is approximately 32 feet per second squared, which is approximately 9.8 meters per second squared, is acceleration due to gravity. Now you'll know which one to use based upon the units that are given in the problem. So if my problem is talking about feet and seconds, then I'm going to use the 32. If it's talking about meters and seconds, then I'm going to use the 9.8. Anyways, and then we have the initial velocity. V sub o is the initial velocity of an object, and S sub o is its initial height. So what I kind of already went through. Alright, so let's look at example 8. It says a Surfside Little League uses a baseball pitching machine to help train players to catch a high fly ball. It throws baseball straight up with an initial velocity of 36 feet per second and from a height of 4.5 feet. It wants us to find an equation that models the height of the ball t seconds after it is thrown. So I'm looking for the height. So I'm looking for S of t. Well, our formula tells us it's going to be negative 1/2 times the gravity. Now, do I use the 32 or the 9.8? So I look up in the problem, I see it's in feet and seconds. Look at the velocity there, 36 feet per second. So that means I'm going to use the 32. I don't know t, so I'm going to do t squared plus my initial velocity of 36 times t plus the initial height. So it says that it throws the baseball straight up with an initial velocity of 36 feet per second from a height of 4.5 feet. So there's my initial height. So there's my equation. Now, think about this as far as a graph. Now, we're not going to use our calculators for this one. This is going to be part of the non-graphing calculator part. So it says baseball that's being thrown up. So this x is going to be my time. The y is going to be my height, which is s. And so it starts at like 4.5 feet. And you know you're throwing the ball up, and the ball is going to have to come back down. So we can also tell, looking at our equation, that it's a quadratic because it's t squared is our largest exponent. And it's a negative in front of it, so we know that it's supposed to open down. So that's all right. But the reason we did this is because when we look at B, it says what is the maximum height the baseball will reach. I want the maximum height, so I'm looking for this point here. This is the maximum, but what is another name for that? That's also our vertex. Now, it says that we're after the maximum height, so that means we're looking for the y value of it. So how can I find the y value? Well, without my calculator. Well, first, I'm going to have to find that x value. And so, to find the x value, remember the x of the vertex we had learned Friday was x equals negative b over 2a. And so we have our equation right there. So we're just going to plug in our b and our a and solve for the x. Once we find x, we can solve for y. Now I'm about to pause this for a second, and this part's going to disappear because I'm going to scroll down. So I'll rewrite some of this. Okay, so I scrolled down here. I redrew my graph. I also rewrote the equation because I can't see my other one now. And that we said we're going to find that vertex right there because that's the maximum using the fact that x is equal to negative b over 2a. Now what I didn't do, and I probably should have done, is I probably should have went ahead and simplified my equation because I've got these two numbers I can go ahead and multiply. So let's do that back up on a. So finish writing that as s of t is equal to negative 1/2 times 32 is negative 16 t squared, and I got plus 36t plus 4.5. So if I want to find the x of that vertex, then I'm going to come up here into the where it says b. So we know then that, well, looking at the equation, we can tell there that this here is my A, here is B, and there's my C. So for the x value, the negative b over 2a, we know that's going to be negative. B was 36 over 2, a is negative 16, and so this gives me negative 36 over negative 32, which ends up giving me like 1.125 exactly. Now remember, you can use a basic calculator, but you can't use a graphing one. So if you know the x value, then you can plug that back into the equation to find the y value. So to find the y, that's going to be our s of the 1.125. So we plug that into our equation. So I'm going to do my skeleton. And plug in that 1.125. And after I do all the calculations, remember, square it first. So do your 1.125 squared, multiply that by negative 16, and then do 36 times 1.125, get that answer, and then add those two plus the 4.5 at the end, and you should get 24.75 feet. So that is the maximum height that the baseball will reach. C wants to know how many seconds will it take to reach that height. Well, remember, time is my x. So right there, they were asking me for the x value of the vertex. And we said that that was 1.125, and we know it's going to be in seconds, because that's what time is in our problem. D asks how long will it take till it hits the ground. I'm sorry, no it doesn't. It says how much time is the ball in the air. Same thing. So we want to know the time, so we're looking for the x value or the t value here of when it hits the ground. Well, the ball starts, I'm up here at my graph right now, the ball starts at that 4.5, and then it's going to hit the ground right there, which, what is that? That's an x-intercept. And so I'm looking for the x-intercept. Now remember, when I go to find it, this graph technically keeps going down to the left, but that's going to be a negative x-intercept, and we're not looking for it. We're looking for the positive one. So let's find it. How do you find the x-intercept? Well, possibly you could factor, but I don't know. With it being a 4.5, I don't even want to try to factor it. So let's use our quadratic formula. So we already identified our a, b, and c. So we know it's x equals negative b plus or minus the square root b squared minus 4ac. Make sure square root goes all the way across, all over, so go back to the equal sign, 2 times a. And so you're going to work these out, and it'll come out that your positive one is going to be approximately, when I round it to 3 decimal places, 2.369, and we're talking about time, so that's going to be in seconds. And then E says to determine the vertical velocity when it hits the ground. Alright, so we're changing formulas here. We're at the vertical velocity. So that was our v of t. And remember, it was negative g times t plus v naught, or the initial velocity. And so we know, because everything's in feet per second, that we're going to use 32 for my g. So it's going to be negative 32. Negative 32 times the time plus 36. And then we want to know the velocity when it hits the ground. Well, we already know from D that it took 2.369 seconds. So that's our time. So we're going to plug that in for T. And we're going to solve that. And we find that it's like negative 39.808, and it's measured in feet per second. So the negative tells us it was going down, and so the velocity at impact, the velocity when it hits the ground, so velocity at impact is, and we're just going to go ahead and say approximately 40 seconds. So remember, the negative just tells us that it was going down, so don't worry about that. So there is our answer to E. Now you definitely could have put the 39.808. Oh, I forgot my feet. Sorry. It's feet per second. So let me back up on that. Yeah, feet per second. Alright, so sorry, what I was saying there is, though, that you could have definitely put the 39.808. Just don't put the negative. The negative told us the direction it was going. Alright, and that is going to wrap up our 2.1 notes. So I want you to finish up the work. Remember, if you have any questions, go ahead and just email me, or you can message me through This It's Learning. Either way, I'll check it each evening. And then if you have any specific questions, I can look at them and make a little video for you. Otherwise, we will be moving on. Alright, so good luck. I hope this helps.